Only mode.
Okay, welcome everybody. I trust you've all had an enjoyable Easter break, and welcome to the Alarm Corp webinar for April. Today's topic is remote video monitoring. My name is Piotr Doletsky and I am the National Product Manager CCD at Alarm Corp. Okay, little bit of housekeeping first for those of you who haven't used the web meeting interface before. Just let's go through quickly the details of what you have on the right of the screen. You will see this little pull-down menu, the grab tabs, etc. Now, for the duration of the webinar, you will all be muted. And we will be taking questions at the end. Now, just to verify that you can all hear me, can you please all press the raise hand button up on the left of your screen? On the left of it. Okay, great. I can see a few hands going up. Thank you. You can put them down now. Okay. Next, there is the questions pane at the bottom, and where you can type in your question. And don't forget, once you have typed your question, to then hit the send button at the bottom. Now, you can type your questions in at any time during the presentation, and I will go through all of the questions at the end of the presentation in the order that they are received. Don't be afraid to ask, only I can see who asks the questions. Okay, with that out of the way, let's get started. This webinar will cover the following. What is remote video monitoring? What solutions are available from Alarm Corp? What is possible with remote video monitoring? Some of the requirements for reliable monitoring. The means of transmitting video back to the monitoring center, and optimizing, getting the best out of your system. So with that, let's get started. Okay, what is remote video monitoring? For the purposes of this webinar, the definition of remote video monitoring, or RVM for short, is viewing video from one or more remote sites. Now, this can be live video or mixed live and playback video for the purposes of alarm verification. And the key thing is that viewing is on a sustained or extended basis rather than a sporadic basis, as in, oh geez, I think something might have happened this morning, let me go back and check the recorded video. So the intention behind remote video monitoring is to more proactively monitor and react to any incidents on site, whatever the site may be. Okay, so what is a video monitoring center? Now, this may be a fully manned, fully staffed control room or guard station, but for the purpose of the webinar, this may also be a small business or homeowner who wants to look at their premises while they are away on holiday or away on a business trip. Now, this brings us to the discussion of site criticality. The level of RVM required obviously depends on the site and incident criticality, the risk of probability of incident, and the seriousness of the incident. Are we worried about trespass, vandalism, theft, and arson, as in the case of a school or university? Are we worried about industrial espionage, in the case of a corporate situation? Or are we worried about potential bioterrorism, e.g. a water utility, or even a quarantine station where sick animals are kept, and some misguided animal activists get in and unwittingly unleash a virus? This may sound Hollywood, but it can happen. Or are we looking simply at a concerned homeowner? So there are some of the issues and dimensions that we want to consider about when we look at remote video monitoring. And obviously the type of site and the likelihood of incident will to some extent define the level of monitoring we have. Okay, so what is available? First of all, we have the Video Central Platinum from Xtralis. Now, this only works with the Xtralis AdPro Fast Trace / Fast Trace 2 family. However, it is still the benchmark for remote video monitoring, so it's sort of just worth mentioning that this exists. This is a very comprehensive package which is suitable for a control room and monitoring center, and it can do video operation and alarm event monitoring and acknowledgement. Stepping down the line slightly, we have TruVision Navigator by Intellogics. Now this is a free software that's supplied with every TruVision DVR and VR. It's backwards compatible with most Intellogics G security DVRs, including the SIM deck. You can view up to 25 cameras on a single screen and up to 75 cameras in total on 3 monitors. It cannot do video wall like Xtralis. However, there is no licensing or dongles required. Now it also supports alarm and event monitoring, but this depends on DVR capability. And finally, at the lowest level, we have web browser functionality. And this is available with nearly every DVR and VR out there today. However, you typically are limited to viewing a single DVR at any one time, but you normally can do live view, some playback, and configuration. Okay, if we look at Video Central by Xtralis, here you have the screen grab, and some of the obvious things that we can see is the live video, and we see at the bottom the real-time events viewer and the menu on the right. So just to bring it up in a bit more detail, you can see that as events come up sent by remote sites in nearly real time, they can be acknowledged as they pop up. You can also change video resolution on the fly. You can set up guards, etc. So this gives you some idea of what a real monitoring software can do. I won't go through all of the features in detail. Suffice it to say, we can do two-way audio. We can do automated guard tools where a system will connect to one side, then connect to another side, all in an automated fashion. In case of site failure, the operator gets notified automatically. You've got a map-driven GUI, and Video Central has been on the market in various guises for more than 25 years, and there's at least 40,000 sites and 400 monitoring stations worldwide. So you can see that this is quite a proven package that is widely accepted right around the world. Video Wall, again, you can see here an example of a video wall application. This is now included with Video Central, and you can have up to 320 cameras at once. So this gives you some idea that if you have got a larger site, whether it's a stadium, whether it's a multi-campus university, whether it's a utility with multiple remote sites, you can actually monitor many of those sites with Video Central Platinum. Okay, TruVision Navigator. Not quite as comprehensive, but again, you can see we've got our sites listed on the left, and we can view multiple cameras. We can select individual cameras for live view. We can select individual or group cameras for playback, save snapshots, and so on. And finally, remote access via web browser. Now, as we said earlier, typically you are limited to a single DVR at a time. So it's not really suited for multi-sites, but you can do live viewing, you can do playback, you can save snapshots. You may be able to export video, and you may even be able to local recording to the local PC on the fly. And you see here some examples of web browsers from TruVision and here from Xtralis. Now, web browsers are not ideal for true multi-site remote video monitoring. Nevertheless, they can be a good fallback in the case of the main PC failing or going offline for whatever reason. Okay, what about the iPhone? It seems that the iPhone is becoming more and more popular, if it isn't already. So I thought we will cover the iPhone in a separate webinar later this year. Stay tuned, because I do believe it warrants a separate discussion. Okay, so what is possible with remote video monitoring? Obviously, all solutions can do live video. Now, the refresh rate and the quality that you see will depend on available bandwidth, and we will discuss the issue of bandwidth in the coming slides. Obviously, single and multi-camera views are possible, and being able to capture live view video and save snapshots. You can do playback of recorded video. There are various search options, such as calendar search, go to date time. You can limit the search by alarms and events. Capabilities vary depending on DVR and package, but again, you can save snapshots from playback, and you can export the recorded video. Remote unit configuration. Configure unit parameters. Save the unit configuration to a file. And particularly useful, upload, download unit configuration for easy cloning of a replacement unit, which can save a lot of time in case a unit does need to be replaced on site. Okay, what else is possible? Remote health monitoring. The periodic polling of remote sites to verify the devices are alive online. Obviously, that's very useful if you've got a large system with lots and lots of devices, and you want to know if a particular device has suddenly stopped transmitting, even if you're not viewing video from that device at the time. You can also do more detailed information, like viewing the hard disk health, is the DVR even recording, has a camera gone into video loss, etc. Things like remote alarm indication, transmission and display of alarms at the remote sites. Now, you can have an external alarm, such as motion detection or an alarm input from a PIR, or you might have an internal alarm. A hard drive has suddenly failed, a cooling fan has failed, a hard drive has filled up and the unit has stopped recording. Again, capabilities do vary somewhat between DVRs, and you would need to check what you want for a particular application. But again, very useful proactive information that you want to know as soon as there is a problem on site so that you can take corrective action. Remote system maintenance, being able to update the unit firmware remotely, being able to reconfigure the unit parameters. Say you want to increase the recording and decrease the recording rate because you're not getting the required number of days. Being able to get on-site configuration and save the file. Let's say that a unit has been installed on site, but the installing technician was in a hurry and disconnected it and set the IP address and nothing else has been done. You can then go in at a later date and just download the previously saved configuration. So some very useful functionality that can be done as part of the remote video monitoring software. Okay, now let's talk about the requirements for reliable monitoring. What do we actually need? Well, first of all, we need the viewing station or PC. We need a high-quality, modern, reliable PC, not like the one that's shown here. We need a robust, up-to-date operating system, and as we all know, invariably today that's going to be some flavor of Windows, but we also know that certain flavors of Windows are more robust than others. It is recommended that we use a dedicated PC that's not cluttered with other programs. The main reason for that is that video viewing is quite processor intensive, and if you have something else running in the background, that can interfere with the decoding of the video. Now, the PC should be on a UPS if we need 24/7 uptime. And while we are in Australia and power failures are not very common, they do nevertheless happen. Whether it's because of thunder or whether there's been an accident and a driver has taken out the local transformer up on a power pole. These things can happen. Next, connectivity, also known as the network. Now, the network can be the network within the monitoring center itself, but it's also the connection to the remote sites. So the network discussion can be broken down into WAN, LAN, ADSL, PSTN, and mobile, and these will be discussed in detail next. Finally, the human factor. Who will be doing the watching? We need to consider access permissions. Who can see what and when? If we are looking at an educational institution, is it appropriate that every person who has access to monitoring can view every camera? Likewise, if we're looking at around, say, residential areas, and we have PTZ cameras that can be tuned to look into people's windows, for example. Do the operators know what to do if they see something happening at a remote site? So basically, we will need a set of policies for the operators that are suited to the application. Obviously, if it's a smaller site with only one viewer, as in the business owner, we don't need to worry so much about this as we do if this is a multi-campus university with multiple security guards and a relatively high security guard turnover. Okay, methods for remote access. Within the local area network, wide area network. In this case, the connection traffic stays within the network. We may not need outside suppliers such as a telco or internet service provider. However, we still need to consider traffic impact, and this will be discussed in the next slide. In the case of ADSL, we need an internet service provider. Now the speeds vary depending on the plan and the distance from the exchange, and we will look at that next. And ADSL can be very good or very bad. Next we have PSTN, Public Switch Telephone Network. So this is the good old-fashioned dial-up. It has very limited speeds, therefore it is not recommended, but it may be the only option in truly remote locations. Finally, cellular, whether it's GSM or 3G or now the next 4G network. Here we're talking about having a mobile phone transmitter at a remote location. Now this is viable only if we do have mobile network coverage. And it may be the only alternative if we cannot run physical phone or ADSL cable. Okay, some comments on bandwidth. If we're talking about real-time standard definition video, in other words 25 images at 4 CIF, in today's H.264 compression that's about 1.5 megabits per second. If we talk about high definition 720p megapixel cameras, this can be 2 to 8 megabits per second or even higher depending on camera and compression. If we talk about CIF and QCIF, this can be less than 256 kilobits per second for real time. So we have some examples here of real-time bandwidth that's needed. So what do we need? What do we need to actually see at the remote station? Full resolution gives us better image quality with more detail, but lower resolution may be acceptable to see what's going on. It's worth talking about dual streaming, and many DVRs support dual streams where you have a high-quality full resolution stream, which is actually what's recorded at the NVR, and a lower quality, lower resolution substream that needs only a fraction of the bandwidth. Lower quality, but lower bandwidth, and here's the trade-off. And both TruVision Navigator and Video Central actually allow you to switch streams on the fly. Okay, so this brings us to the topic of optimizing remote video monitoring. The trade-off. If we do have limited bandwidth available, we need to compromise or trade-off on fundamentally 3 dimensions, these being video resolution, the video quality / compression, or the frame rate / refresh rate. Now remember, we're talking about the transmission rate here, which is often different to the recorded rate. So if we look at resolution, higher resolution gives more pixels and hence more detail, but it needs more bandwidth. Lower resolution may be acceptable to see what's going on. So we may want to look at reducing megapixel resolution down to VGA. We may want to look at reducing standard definition 4 CIF down to 2 CIF or even QCIF. We really need to look at what do we need for the application versus the bandwidth that we have available. Quality / compression. We can set the lowest quality that will provide sufficient detail. Now, lower quality means we have more visible compression artifacts. Again, the question is what is acceptable for the application? And the final dimension that we can look at is the frame rate. If we lower the frame rate, we may be able to use higher resolution and higher quality. Obviously, the holy grail is real-time at 25 images per second. But is it really necessary? For many applications, even 1 to 5 images per second remote transmission is going to be more than adequate, and it's a fraction of the bandwidth. So I guess the real key is here, we look at the application, we look at the available bandwidth, and we have to trade off these 3 dimensions to get the optimal resolution for the site in question. Okay, more on local area network, wide area network access. Using WANs and LANs internally within an organization may be the simplest and the cheapest, but this is usually only viable within large organizations that already have the network infrastructure in place. Typically, this means we are dealing with multi-campus universities, banks or corporates, or possibly larger utilities. Now, inevitably, we are reliant on the IT staff or network administrators to make it happen. And we need to consider the impact of video bandwidth onto the existing network. Remember that the network pipe to a remote office may actually be quite small, only a few hundred kilobits per second. Now, bandwidth. You don't know what you had till it's gone. We said earlier that video traffic is bandwidth intensive, particularly for megapixel cameras. So, if we are talking about a local area network, will this bandwidth be available on a 24/7 basis? How will us, as the video monitoring center, using this bandwidth impact on other network users? Now, we need to also understand the impact of other network traffic on the video. For example, an automated backup that happens at 8 p.m. every night. Impact of multiple users wanting to view the same camera. We may need to look at multicasting. And that brings into question, do the corporate policies permit multicasting on site? And finally, understand the impact of constant bitrate and variable bitrate on bandwidth and quality. And let's explore that a bit further. Constant bitrate is just that. We try and maintain a constant bitrate. Now, from a network administration perspective, that is very, very good. We know how much bandwidth we use, and we can allocate the bandwidth. However, constant bitrate is reliant on varying the compression quality depending on how much detail there is in the image. Obviously, with lower amounts of data in the image, constant bitrate can give better quality. But if the image gets very busy and we're not allowed to increase the bitrate, we have to reduce the quality. Variable bitrate, on the other hand, allows us to maintain the quality but vary the bitrate depending on what's needed. This is great from a video quality perspective, but not so easy for network administrators to handle. Likewise, it's not so easy if we have a fixed bandwidth ADSL connection. Which brings us to ADSL. Now, ADSL is asynchronous digital subscriber line. The asynchronous portion means that the download speed from the telephone exchange is faster than the upload speeds from the remote side back to the telephone exchange. So, for example, if we have a 1 megabit ADSL link, the upload speed may only be 256 kilobit. Remember that video streaming from the DVR will be at the lower speed. And finally, the achievable speed depends on the distance of your site to the telephone exchange. Now, if you look at this curve, this is provided from one of the ISPs. At very close distances to the telephone exchange, at ADSL2 we can have over 20,000 kilobits per second. But as soon as we get over 3,000 meters or thereabouts, then we're down at the old-fashioned ADSL speeds. And as we get even further, the speed drops away quite significantly. So the key takeaway here is, even though with ADSL we may have a very high theoretical speed, the actual speed that's achievable may be lower because of how physically far the site is from the nearest telephone exchange. Okay, more comments on ADSL2. Where is my ADSL bandwidth gone? Now, this is more in the context of residential or small office, home office scenarios, which have their own challenges for remote video monitoring. Typically, these will be going to an ISP, whether it's BigPoint, whether it's TPG or Dodo, or others. Now, various ISPs have various plans, and uncapped plans aren't always uncapped. Check the fine print. These might often be worded as fair use or reasonable use policies. So what will happen to the speed once any applicable usage cap is exceeded? And again, remember, video traffic chews up lots of bandwidth. So will the connection speed be shaped to a lower speed? Or will there be extra per megabyte charges? And will these apply just to downloads or also to uploads? And importantly, the impact of other users of the ADSL connection. In particular, in a typical home scenario, we may have little Johnny who's been busy BitTorrenting the latest season of Game of Thrones or the Twilight Saga, and they're now seeding the download for other users. And that can take up all or most of our available upload bandwidth. Likewise, is another user using Skype for video calling? Or is little Johnny uploading their latest skating video to YouTube? Again, all of these things can impact on the available upload bandwidth, and At the video monitoring center, we may not be aware of this. All that we see is that suddenly there is a problem with the video, because apps like Skype and BitTorrent can use a lot of bandwidth. So this may not be applicable in every case, but it is something that is worth being aware of. Okay, PSTN, good old-fashioned dial-up, or maybe not so good old-fashioned dial-up. Don't take it for granted that ADSL will be available everywhere, particularly for remote areas, rural areas. The site in question may be too far away from the exchange for ADSL to work, or the copper line may be of insufficient quality. So unless the telco does the upgrade, we may be stuck with dial-up, and in that case our maximum upload speed is limited to 33.6K. Even though we may have a 56K modem, the 56K refers to the download, not the upload speed. So you can see that the moment we go to dial-up, we are very much limited in what we can do with remote video monitoring. And this is something that traditionally the previous generation of Xtralis fast trace was actually very good at handling low bandwidth. Going mobile, GSM, 3G, etc. This may be the only option if hardwired connection is not available. However, the network coverage is often very poor in remote or rural areas. So you need to check what data speed will be available on site. Now, data speed will depend on whether we can connect as GSM or 3G. Now, we've all heard about the latest 4G network, which speeds to be much, much higher. But as of today, the coverage is still very limited. Most importantly, check the plan to avoid bill shock. Many telephone plans have got separate rates for voice traffic and data traffic. And again, remember, video traffic chews up a lot of bandwidth. So coverage or lack of coverage and the plan and associated ongoing costs need to be considered. And this may make mobile viable or unviable. It will depend on the situation. Okay, so what happens when things go wrong? Loss of connectivity. What happens when the network fails? And by network we mean could be the network within the monitoring center, or it could be the link between the monitoring center and the remote site. Will the image disappear? Will the image freeze? How quickly will the operator know that there is a problem with the network? And who is responsible for restoring the network? Is it the company's IT department? Is it the relevant telco? Or is it the relevant ISP? And this is particularly in the case of ADSL connections. Did the ADSL go down because of the ISP being down? Or was there a physical problem with the phone line? If there is a device failure in the field, this is where the device self-monitoring or the heartbeat function is critical. How quickly will the operator identify the problem? That it is the device that's gone offline and not the connectivity. And then who is responsible for solving? Is it the site owner or is it the security company? We need to consider the time to get the site back online. Particularly if the site is remote, we need to factor in the travel time. And when the person does get on site, do they have enough knowledge to adequately configure the replacement machine? And if they don't, can they get it online sufficiently that we can then log in remotely and do upload of the configuration? If things go wrong, part 2, monitoring center equipment failure. What happens if the main monitoring center PC fails? Is there a backup? Does it have or does it need a licensed dongle? Another solution in the interim may be to use the web browser of another PC. Now, what is the impact on site security if no monitoring is taking place? Power failure. Ideally, we want all DVRs on site and the monitoring center of a UPS. Now, we need to balance the UPS size and hence cost with the likelihood and expected length of power failure. How quickly can the power utility restore power? And in the case of a remote site, this may take some time. Now, what happens to the site security if the UPS runs out of power and the power is still not being restored and we no longer have any video monitoring. So again, these are things that should be considered as part of a remote video monitoring setup and proposal. Finally, security and passwords. Remote video monitoring often requires that remote DVRs are on public IP addresses. This means they are publicly accessible. So have the login credentials been changed from their defaults, e.g. admin1234? If the passwords have been changed, who keeps the details? If that person leaves the company, has a heart attack, or is hit by a bus, who else knows? Now this is not a trivial issue because resetting a lost password may be problematic. It may involve returning the unit back to the supplier or to the factory. It may require having a technician on site at a particular date and time to use a temporary unlock password. You may need to uninstall and reinstall the monitoring software if the password to the monitoring PC has been lost. You may even need to rebuild the PC workstation. Now, none of these things are impossible. However, they can be time-consuming and difficult. So again, just something to be aware of, that password security and who keeps the passwords is not a trivial thing. And that's not just for remote video monitoring, but all video surveillance systems in general. Okay, conclusions. Remote video monitoring is a powerful tool. We see that we have various solutions available depending on applications and the criticality of monitoring. The critical requirement is that reliable equipment and network infrastructure, particularly whether we're talking about network or ADSL, so that we can transmit the video back to the monitoring center, whatever that monitoring center may be. And as we saw, different remote access methods have their strengths and limitations, and understanding these is critical to success. Okay, would you like to know more? More information, including brochures and data sheets, may be found on our website, www.alarmcorp.com.au. If you haven't already, I would urge you to subscribe to the Alarm Corp Pulse to receive new product information automatically. Register online to get full access to our e-commerce platform, or contact your nearest Alarm Corp representative, Jeff Rushton and Diane Brazil in New South Wales. Their email addresses and phone numbers are listed, or Mr. Stephen Digger in Victoria, SA and WA. Or you can contact myself directly. My number is 0421 378 334, and my email address is prd@alarmcorp.com.au. Okay, if you've enjoyed this webinar and found it informative, be aware that there will be a CCTV webinar every month on normally the second Wednesday of each month. Topics included for this year are the iPhone as a surveillance tool, CCTV fundamentals, network video system design, optic fiber fundamentals and system design, and optimizing DVR configuration. Now, this is not all the topics. This is just a selection of what we will be covering this year. Go to our website and click on the resources/webinars link, and we look forward to your participation. If you haven't done so for a while, check out our website. We have always new information and up-to-date specials. Okay, that concludes the webinar, and now it's over to question time. As we saw earlier, please type your question and hit send, and I will go through the questions as they appear. Don't forget to press the send button at the end. Okay, so we're now ready to take some questions. Okay, we have a right. First question. Thanks for the presentation. Are the slides available for future references? Also, slides from Camera Webinar Basics of last month. Okay. All of the past webinars are available for download on our website, and today's webinar will be available in a couple of days' time as soon as we process the recording and etc. So yes, any of our webinars may be accessed from the website. Okay, next question. Okay, it's just been pointed out to me that the address for my Sydney office in my presentation is not quite correct. Yes, in case you didn't know, Alarm Corp in Sydney has recently relocated, so I do need to update my slides. Thank you. Okay, next question. Is there a design calculator that can be used in bandwidth requirements? We do have recording calculators for a range of our DVRs, and they give you a very good approximation of how much bandwidth you need at a given image quality, at a given resolution, and at a given frame rate. Now, while these are normally used in the context of how much hard drive space I need and how many days storage, because they give you the bandwidth in kilobits per second, you can use them as a proxy to work out how much streaming bandwidth you need. I hope that answer is sufficient. If you want, send me an email and I can email you the various recording calculators that we have available. And the good thing about them is that if you look at, say, a particular megapixel camera with a particular compression, the bandwidth is not going to vary hugely between, say, an Interlogix camera and an Axis camera or a Panasonic camera, because ultimately, if we're talking about, say, streaming 720p at 12 images per second, all of the bandwidths will be probably within 5 to 10% of each other, because at the end of the day, we're trying to transmit roughly the same amount of data. So that is one thing we can use as a proxy. Okay. Are there any more questions?